Okay, so we're on the 8.1 extras page. I'm going to tell you what to write in. I'm also going to tell you what to highlight at the end that is on your quiz on Friday. So, similarity. There are figures that are the same shape but not necessarily the same size. What do we know about the corresponding angles? What are they? Congruent. So go ahead and write that in. Corresponding angles are congruent. But in similar figures, they're not the same size. So what do their sides have to be? Proportional. Proportional. Okay, so in exercise 1, it says first find the scale factor. I would write above it just to remind yourself what a scale factor is. It is the number that is multiplied to all the sides of similar polygons. It is the number that is multiplied to all the sides of similar polygons. So we need to figure out what was multiplied. If it doesn't, it will say it most of the time. It'll show you like an arrow. I want to know what number I multiplied to all of these sides to get all of these new sides. So pick a side off of this first figure. He said BA, hold on. Which is 12. What does BA correspond with on the second figure? FE. So 12 times the scale factor, we don't know it, so we call it X, it represents the scale factor, gives me a side length of 4.8. We started with a decimal, our scale factor is going to end up being a decimal. Divide by 12, what is the scale factor? It's 0.4, yeah. Oh. So the scale factor, you want to write it, the scale factor is 0.4. It doesn't matter what sides you picked. If you had picked 9 and 3.6, 9 times the scale factor gives you 3.6. Any way that you do it, you still get 0.4. Remember how I said we prefer fractions, we prefer improper fractions over decimals? You started with decimals, you're going to end up with a decimal. But had you done 10 and 4, 10 times the scale factor gives you 4. Divide by 10. What does this reduce to? 2/5. This is equivalent to 0.4. They're the same thing. So if your question looks like this, where you have no decimals, you need to leave it like a fraction, which would be 2/5. Okay, but in ours we had decimals. But these are the same. We all okay with the fact that 2/5 is the same as 0.4. Okay, so that's our scale factor. The next thing we're going to do is list all the pairs of congruent angles. Remember when we used to look at this? We're going to do it again. Okay, I want you to write in, what do we call this statement?
Congruency?
Almost. Similarity statement. So if you don't remember, this is called a similarity statement. Okay, make sure you know I'll be asking you to make them a lot today, similarity statements. But remember that these are written in the correct order where we can just look at this statement and list the pairs of congruent angles. We can start with angle A. It's the first letter in the first figure. What does A correspond with in the second figure? E. So angle A is congruent to angle E. You can keep going. Angle B is congruent to angle F, agreed? Angle C is congruent to angle G. And then the last one would be angle D is congruent to angle H. All right, and then the last thing that we do is write the ratios. What does a ratio look like? Looks like a couple things. Here it's going to look like a fraction. You're going to write the fractions of the corresponding side lengths in the statement of proportionality. How many sides are there in this picture? There are 4. So we're going to end up having 4 fractions like this. kind of already highlighted some. If I say, let's say AB. If I say AB, what's going to go in the denominator? EF. If I say BC, what goes in the denominator of our second fraction? FG. Okay, if I say CD, GH, and then the last one, AB, no, AD, sorry, it's the letter D. AD, or DA, doesn't matter. But if I say AD, what goes in the denominator? EH. Okay, what matters is that the top is all from the same shape, the bottom is all from the same shape. And, you know, the corresponding parts are together. Okay? Here's what I want you to highlight. Corresponding angles are congruent. Corresponding sides are proportional. Picked it up off the table. Corresponding angles are congruent. Corresponding sides are proportional. You want to highlight it. Some other things you want to highlight. Scale factor. You need to know the definition. You need to know the process. You'll probably be asked to write like what the scale factor is, but not like the memorized version. It's the number that you multiply by all these sides to get your new side lengths. Okay? And then you'll just need to be able to answer this question in general. Be able to find the congruent angles and write a statement of proportionality. You're going to have an exact question like this, just different shape. Okay. All right, next section. The polygons are similar. Find the value of x. Also, what is this scale factor? So let's talk about this. They're similar. Is x an angle or a side? It's a side. What do we know about the sides? They're proportional. It's okay. They're proportional. So we're going to set up a proportion. I always use x first because that's really what we care about is x. So if I put x in the numerator, the denominator will be what x corresponds with in the other shape. So what does x correspond with? 1.5, yeah. Okay, since x is in the numerator, the other numerator needs to come from the same shape. So what's going to go in my other numerator? 8. And 8 corresponds with 2. Cross multiply. X times 2 is 2x. 1.5 times 8 is 12. Yep. Divide by 2. X is 6. All right, and then it says, what is the scale factor? So normally it will tell you from what picture to what picture. If it doesn't, we read from left to right here in the great US of A. So we're going to figure out what number was multiplied by all of these side lengths to give us, you know, a bigger picture. So, definitely not.
Whoa, no.
Yeah. 2 times the scale factor will give me a length of 8, and it's going to be 4. So the scale factor is 4. So remember, it's a number that's being multiplied, the scale factor. The same thing, 1.5 times 4 gives me the length we said was 6. So 4 is a scale factor. What if it was from the right to the left? What is the scale factor from 8 to 2? It's not 4.
1/2? Wait, no. 3/4.
It'd be 1/4. It'd be the reciprocal.
I was close.
So it'd be the flipped. So from 2 to 8, it's times 4. From 8 to 2, it's going to be times 1/4. It's the flipped. Okay? 2 is 1/4 of 8. So there's that. That's why it matters from what direction to what. I'll normally list it. If I don't, you can just do left to right. Okay? The second, we've got 2 triangles. Okay, we want to find x. What does x correspond with in the other figure? 15. So x is between the 2 arcs and the blank angle. 15 is between the 2 arcs and the blank angle. So x over 15 equals, x is in the numerator, so we need to take from the same triangle as x. So what's going to go in my other numerator? 6, and that corresponds with 10. Cross multiply, you get 10x. 15 times 6 is 90. Divide by 10. X equals 9. And then again, what is the scale factor? So you want two pairs of corresponding sides. So we're going to use 6 and 10. 6 times the scale factor, we don't know. You can call it x, you can call it whatever you want. I know there's already an x in the question, but I'm going to call it x. Gives me a length of 10. So 6 times the scale factor equals 10. Divided by 6. This does reduce. So what does it reduce to? 5 over 3. So you're not making it a decimal, y'all. If you don't have any decimals in the picture, I do not want a decimal. It is 5/3. 5/3. So that means 6, right? 6 times 5 over 3 should give me 10. What's 6 times 5? 30. 1 over 3, or 1 times 3 is 3. This reduces to 10. Okay, so we were correct. Our scale factor is 5/3. What if I wanted to go the other way? What if it was from the bigger triangle to the other? It'd be 3/5. It'd be the flipped. Okay. I think that's all to mention in this picture. You'll have a section like this as well. Are these similar? If not, why? If so, write a similarity statement. What do we know about the angles in similar figures? Good. The corresponding angles, no. They are congruent. And then what do we know about the sides? Are proportional. I'm just going to abbreviate. You have it at the top of your page. You highlighted it already. So we're going to go through these and decide if they're similar. If not, we're going to explain why they're not. And if so, we're going to write a similarity statement. So number 4, let's start. Are the corresponding angles congruent? No. All of the angles in the first one are 90. Are there any 90-degree angles in the second one? No. So these are not similar because you could say the corresponding angles aren't congruent. I mean, that's really the only thing. You could say all of these were 90 and none of those were 90. I mean, mainly the reason is the angles. Okay, remember that similar figures, they're the same shape. Are these two the same shape? No. One is a square and the other is a rhombus. Okay, so they're not the same shape. Number 5, you'll actually be able to tell by the end of today. Today's lesson is about triangles. But we're going to use what we've already known to kind of answer this anyways. Let's talk about the angles. We've got a right angle and a right angle. And then we know that these two are congruent, right? So just to show you why the answer is the way that it is, pick a number between 1 and 90.
43.
Why you got to be weird? 43. If this angle is 43, what's the measure of angle K? 43. So I want you to think about this for a second. How many degrees fit inside of a triangle? 180. How much is taken up by the 90 and 43?
133.
Yep, sorry. No, it's 3. I'm subtract. Subtract, that means the measure of this angle is? It's 47. It's 47. It's okay. I wasn't asking. It's okay. Look at the other one. We got 43 and 90. What's 43 plus 90? It's still 133. 180 minus 133 is 47. So, are the corresponding angles congruent? Yes. Okay, we made up these numbers, but I'm just showing you. You learned a theorem, it was probably in September, that if two angles are congruent to two angles, that means the third angle is also congruent. We learned it a long time ago. I just showed you with numbers. The corresponding angles are congruent. Let's see if the sides are proportional. Okay, so pick two corresponding sides that you know both of their measures on both triangles.
35 and 20.
Sure, let's try 35 and 20. Let's find this. We're going to find the scale factor. We're just going to go left to right because that's how we read. We need to see if the scale factor is the same. Okay, it'd be the same for all of the sides. So 20 times the scale factor would give me a length of 35. Divide by 20. This does reduce. What are 35 and 20 both divisible by? 5. 35 divided by 5 is? And 20 divided by 5 is 4. So the scale factor for those two sides is 7/4. We need to see if the other sides also have 7/4 scale factor. So pick another two sides we know. Yeah, 12 and 21. So again, reading left to right. So 12 times the scale factor gives me 21. Divide by 12. What are both these numbers divisible by? 3. 21 divided by 3 is? And 12 divided by 3 is? 4. So they have the same scale factor. So these two are similar. So we're going to write a similarity statement. A similarity statement says this shape is similar to this one. Whenever you name a triangle, you got to have a triangle. Go ahead and name the first one with letters. Triangle. What is it? A, B. Yeah, it's fine. It's not wrong. I should ask him. It's similar. Put the squiggle. Triangle ABC is similar to triangle. What does A correspond with? K. And then B corresponds with M. And then C corresponds with N. So B and M both have right angles. Okay, and then the last, are the corresponding angles congruent? Yeah, it's 90 and 90, right? So the angles are good. Let's talk about the side lengths. Let's look at 4. 4 is the short side on this rectangle. What does it correspond with on the second rectangle? 4. So what do I have to multiply by 4 to get 4? 1, which would mean the scale factor would have to be 1. Which would mean on this one, 9 times 1 would give me, yeah, and not 6. So are they similar? They are not. So we're going to say not similar. And it does say if not why. You can write a couple things. You need to be using geometric words. So either that they don't have the same scale factor or that the corresponding sides aren't proportional. Either would be fine. Which one do we want to write? Okay, that's fine. They don't have the same scale factor. So I would expect to have a section like this as well on the quiz. Are they similar? If so, write a similarity statement. If not, explain why. And then the last question we have to review. Your neighbor has decided to enlarge his garden. The garden is rectangular. So let's draw a rectangle. Do we want it to be standing up or sideways? Sounds good. We're gonna do it sideways. Make sure you leave yourself enough room because we're gonna make it a bigger garden. So, give yourself room to draw a larger garden. Okay, so with a width of 6 feet. Can I help you? Okay, we're going to keep going, you weirdos. 6 feet. And a length of 15 feet. The new garden will be similar to the old one. So what shape will our new garden be? It'll also be a rectangle. It's just going to be bigger. This time it has a length of 35 feet. So you see how it says length? It needs to be corresponding with the length of the other rectangle. So it needs to be in the same spot. So 35 feet, 15 feet. Can we all see it? Find the perimeter of the original garden and the enlarged garden. So we're going to find the perimeter of the original. You'll want to write off to the side. Bless you. And you'll want to find the perimeter. We're going to call it the new garden. Okay, so we want to find the perimeter of both. So, I know that there are many ways to solve a question. And I know one of the things that you hated about Algebra 1 is that you had to do it the one way and that was it. I am asking you to do this the one way because you will need to use this formula in Chapter 11 and it will get harder. If you do not memorize it now, it's going to screw you over later. Do we understand each other? I love y'all and I know there are many ways to solve this. But I'm going to teach you the formula. I need you to use the formula because it gets harder. Okay? So, you saw it on the flipped classroom. You take a side from the first over a side from the second, and you make it equal to the perimeter of the first over the perimeter of the second. Okay, so the things to remember about the sides have to be corresponding with each other. Just going to mark that. They have to be corresponding sides. So we can't use 6 because we don't know the corresponding side length. Okay? So what is my side for my first shape that I'm going to use? Yeah, you all said different numbers. 15.
How will we know what these?
You want to use the corresponding sides.
Oh, okay.
So 6, I don't know the corresponding width. Yeah. So we're going to use 15, and then 35 equals the perimeter of the first. So perimeter of the first, you're going to add up all the lengths. So we got 6, we got 15. What's the measure of this width over here? Also 6, and then down here is 15. Add them all up, and we get 30 plus 12 is 42. Okay, over the perimeter of the second. Do we know the perimeter of the second?
No.
We do not. So we can say x or p, doesn't matter. We can put x. We're solving for the perimeter of the new. We can write that we already know the original perimeter was 42 feet. I mean, we already answered half the question. To find the perimeter of the new, we're going to cross multiply. So we'll get 15x. 35 times 42 is 1,470. Divide by 15 is 98. So we would say 98 feet. So, what is the only difference between the perimeter formula and the area formula? What did we do with the area? It's squared. Which part was squared for the area? The sides were squared. Here's why you need to know the formula. Literally, all I have to do is do this, and instead of perimeter, I do area. And then volume, you're going to end up cubing. So that's why you need to know this formula so that later on, we just add one small thing to it. Okay? We're going to go to 8.2. That was review over 8.1. 8.2 is all about triangles. Triangles are special to us. We've got 3 examples, and then that's it. That's all we do. It's about triangle similarity. If you remember, we had a whole chapter about triangle congruence. You learned 5 theorems. I'll list one of them so you spark your memory. You had hypotenuse leg. You had angle, angle, side. What were the other ones? Side, angle, side, 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 angle, side, angle. You had 5 of them. There's 2 for us in similarity. And one of them is called AA. So what do we think AA stands for? Angle, angle. Okay, so that's it. If 2 angles are congruent to 2 angles, the triangles are similar. That's it. It only applies to triangles, and we'll talk about it. Before we do, let's refresh our memory on similar figures. You want to make sure you highlight this because this is on your quiz. You've already seen this, just in a new place now. Similar figures have the same shape, but proportional size. So you're writing this in the top blank. They're the same shape, but proportional in size. Same shape, proportional in size. They have congruent blanks. We've written this so many times. Can you guess that it's important now? They have congruent what? Angles. And they have what kind of sides? Proportional sides. You're going to get tired of writing it, and I don't care. That means you're going to memorize it. So, same shape, proportional sizes. They have congruent angles, and then proportional sides. Remember the squiggle? What does the squiggle mean? Similar. I just gave you a silly example of 2 stars. They are similar. They're the same shape. They're literally different sizes. But again, in this section, we're just talking about triangles, and that's it. We kind of talked about this earlier. If 2 angles in a triangle are congruent to 2 angles in a triangle, then the triangles are similar. You don't need to know the scale factor. You don't need to know anything else about them. But if you have 2 angles congruent to 2 angles, The triangles are similar. And that is it. All I'm asking you to do in this section, I've already lost some of you. Stay alive. Come on. It's not hard. You're going to do whiteboards in a second. All I'm asking you to do, you're going to be asked, are they similar? If so, why? Here's why they're similar. This angle is congruent to this one. This angle is congruent to this one. Here's a similarity statement. That's the extent of what you'll be asked to do. Okay? Be able to tell me which angles are similar and then write a similarity statement. So do not die. Thomas Fryer, stay alive. Here we go. First example. I know some of y'all, I'm just telling you. Determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. So, do we have any information about the sides? No, we just have information about the angles. But I know that if two angles are congruent to two angles, then I have similar triangles. It looks like I got 26 and 90 and 64 and 90. Do I have all the information to come to my decision? No. What can I do to have all the information? Add them and then? Subtract from 180. What's 26 plus 90? What's 9 plus 2? It's 116, yeah. Subtract that from 180, we get 64. So in our other triangle, what's this blank angle? 26. So do we have two angles congruent to two angles? Yes. So we have similar figures here. Okay, so if they are, write a similarity statement. Remember, a similarity statement just says that this shape is similar to the other one. So let's name the first triangle. When you name a triangle, you draw a triangle. Go ahead and name our first triangle. CDE, sounds wonderful. CDE is similar, so the squiggle, to triangle. I said C first. What's going to correspond with C in the second triangle? K. And then D corresponds with G. And then that means E corresponds with H. It says explain your reasoning. Okay? Our reasoning is that we got a triangle. Normally it would say, write the theorem. But we're just going to list which two angles made us come to that decision. So, pick two angles that are congruent. Okay, so angle E is 64 degrees. It is congruent to angle H. They're both 64. Okay, remember that the theorem says two angles are congruent. Right? So pick another set of angles that are also congruent. Angle C is congruent to angle K. You could have also, I'm just going to write off to the side, you could have also listed angle D is congruent to angle G. Any two of them would have been correct. So yes, they're similar. Here's the statement, and here's why. We had two angles congruent to two angles. Flip the page when you're ready. Show that the two triangles are similar. So here are some things to look for, and we need to remember. I want you to write this down towards the bottom. We need to remember about vertical angles, though I believe that they are marked for you in these pictures, but they won't be forever. Vertical angles are formed by two straight lines, and they are located across from each other. So go ahead and write in vertical and draw our picture here. Okay, what do we know about the measures of vertical angles? They're congruent. So if you see vertical angles and they are not marked congruent, you can mark them congruent. Another thing is overlapping angles. And I will show you. Overlapping angles. So you remember how we used to have sharing walls? Here we're talking about angles, but it's the same idea. My daughter would call this a baby triangle, and then a bigger triangle, right? There's two triangles here. But they both have this angle in common. So this angle we would be able to call congruent to itself. If we were to peel these two triangles apart, the angle K would be congruent on both of the triangles. So if you see any overlapping, which we're going to see in a second, they'll be marked congruent. Okay, and then the last thing is, if you see parallel lines, you want to be thinking of transversals. How would I know two lines are parallel? What would be shown on those lines? Little triangles, yep. And oftentimes in your book they're going to be red. Okay. You want to be thinking of relationships between transversals. So angles that are on the inside of double lines on opposite sides of the transversal. What do we call these angles? Alternate interior. All right, the same thing with on the outside of the double lines on opposite sides of the transversal. These are called alternate exterior. And then the last ones you'll want to highlight because you're going to see it tomorrow for sure. So you see how tomorrow you have a practice worksheet? You're going to see this one. And it's called corresponding. I don't have enough room to write it, but corresponding. 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 They're in the same spot on their intersections. So top left, top right, bottom left, bottom right, bottom right. Those are corresponding. And they're also congruent. So if you don't have enough information in your picture, you want to be going through this like checklist. Do I have any vertical angles? Do I have any overlapping angles? Do I have any of the transversal angles? Okay. I do think that one of these is more marked on your paper than it is on mine. What is marked on this one that I don't have? These are marked?
Yes.
S and okay. Okay, so we'll get there in a second. I just know it didn't come on my screen for some reason. Let's talk about A. It says show the two triangles are similar. So is it asking if they're similar? No, it's saying show that they're similar. They're similar. Do you have any information about their side lengths? No. They're triangles, and we could talk about their angles. These are similar because they have two sets of angles that are congruent, and we will list the two angles that are congruent. We obviously see the 52 and the 52. The only hard part that people find with these is naming angles. Can I name this first one? Can I name it angle B? No. Because there's technically three angles at B. Okay, so we can't just say B, we have to name it with three letters. Yeah, so we would say angle A, B needs to be in the center, so A, B, E. B needs to be in the center if you're naming that as the vertex. A, B, E, or E, B, A, either one. It is congruent to. This bottom angle is also 52. Can I name it angle C? Yes, I can, because there's only one angle at C. I prefer, if it's possible for you to write one letter, please just write one letter. Like C, D can be written as one letter. Can E be written as one letter? No, same idea. It's got two angles up here. Could A be written as one letter? Yes. Yes. We'll talk about it. Okay, so that's one set. The other set is not super visual. You'll need to go through the list. Do we have any vertical angles? No. Do we have overlapping angles?
Yeah.
Yes. Where do they overlap? At angle A. So, we can say angle A is congruent to angle A. Because there's only one vertex at A. There's not another ray coming out of A, just the two. Even though it's two triangles, if I split them apart, it's still angle A. Okay? The second, you already had this information, but why are the inner angles marked congruent? They're vertical. Okay, so that would have been the reason. And then these two, I just want you to understand, you've got two parallel lines and a line cutting through them. A line cutting through them. We call these, that's transversal. So these are alternate interior to each other. Okay, if these lines continued forever and ever and ever, they're alternate interior. They're inside of double lines, and then opposite sides to transversal. So we're just going to list them as congruent. Do we want to do the vertical first?
Yeah.
Sure. Can I name it angle V? No. So what do we want to name it? SVR is congruent to? What does S correspond with? U. So we'd say U and then V and then T. Okay, so we've named the vertical angles. Now to name the other two. Do I need three letters to name S and U? No, there's only one angle at S and one angle at U. So angle S, trying to find a room. Angle S is congruent to angle, what do we say, U. Yes, ma'am. With 3 letters? Would it be wrong to write it with 3 letters? No, it's just harder for me to read, which means it's hard for me to read. Yeah.